Well, hello, boys and girls. Welcome to Math Lesson 1.7. This is page 37 if you're following along in your book. We are doing problem solving today with tens and ones. Our essential question is, how does finding a pattern help you find all the ways to show a number with tens and ones? Yesterday, in lesson 1.6, we noticed some patterns as we were trading a 10 for ones or trading ones for a 10. And so let's do a little more exploring today and see if we can find some more patterns. We're going to start out with Jessie Bear.
How does finding a pattern help you find all the ways to show a number with tens and ones?
Hi, friends! Blaine and I are very excited. We're going to a birthday party in the park, and we're in charge of bringing the party hats. We're trying to figure out how to carry the hats to the park. We can carry them in boxes of 10, or we can carry single hats. There will be 24 people at the party, so we need 24 hats. I wonder if there's a pattern to help us figure out how to group the hats so we can carry them. Come on, let's find.
Gail needs to buy 34 pencils. She can buy single pencils or boxes of 10 pencils. What are all the different ways Gail can buy 34 pencils? Asking yourself questions will help you solve the problem. What do you need to find? You need to find all the ways Gail can buy 34 pencils. What information do you need to use? She can buy single pencils or boxes of 10 pencils. Let's use base 10 blocks to show one way Gail can buy pencils. We'll use a tens block to represent one box of pencils, and a ones block to represent a single pencil. What block should we use to show 34 pencils? 3 tens blocks and 4 ones blocks. We can use a table to record this first way Gail can buy 34 pencils. What is another way she can buy the pencils? Let's trade a tens block for 10 ones blocks. We now have 2 tens blocks and 14 ones blocks. How do you record this in the table? Gail can buy 2 boxes of pencils and 14 single pencils to buy 34 pencils. Let's trade another tens block. We now have 1 tens block and 24 ones blocks. Record this in the table. Gail can buy 1 box of pencils and 24 single pencils to buy 34 pencils. Now let's look for patterns in the table. As the number of boxes decreases by 1, the number of single pencils increases by 10. This is because we trade 1 box for 10 pencils. How can you use the pattern to find another way Gail can buy 34 pencils? The number of boxes will decrease by 1, so there will be 0 boxes. And the number of single pencils will increase by 10, so there will be 34 single pencils. Is there another way for Gail to buy the pencils? We can't trade any more tens blocks, so there isn't another way. Mr. Winter is putting away 46 chairs. He can put away the chairs in stacks of 10 or as single chairs. What are all the ways he can put away the chairs? Let's use a table and base 10 blocks to help us solve the problem. Then we'll use patterns to solve the problem. 4 10s and 6 1s represent 46 chairs. In the table, record this first way Mr. Winter can put away the chairs. 4 stacks of 10 chairs and 6 single chairs. To find another way he can put away the chairs, you can trade a 10s block for 10 1s blocks. Record this in the table. 3 stacks of 10 chairs and 16 single chairs. Here's another way he can put away the chairs. You can trade a 10s block for 10 1s blocks again. Record this in the table. 2 stacks of 10 chairs and 26 single chairs. What patterns do you see? As the number of stacks of chairs decreases by 1, the number of single chairs increases by 10. Use the pattern to show another way Mr. Winter can put away the chairs. Select your answers and then click Check. Great job! 1 less than 2 is 1. And 10 more than 26 is 36. Good job! 1 less than 1 is 0, and 10 more than 36 is 46. So these are all the ways Mr. Winter can put the chairs away. Now let's practice with the person. Now try your...
Thanks for helping me figure out a pattern for carrying the party hats to the park. See you soon.
So let's look at our problem here. Gail needs to buy 32 pencils. She can buy single pencils or boxes of 10 pencils. What are all of the different ways Gail can buy 32 pencils? Okay, so to unlock the problem, what we need to do is ask the question, what do I need to find? Well, we could also underline that, and that is, what are all of the different ways Gail can buy 32 pencils? And we can trace over this, ways Gail can buy 32 pencils. So you could trace over that in your book. Next, we look for what information do we need to use? She can buy single pencils, and single means just one, or boxes of 10 pencils. So we can underline that. And a box of 10 pencils is like a 10. We can think of that as a 10, and we can think of the singles as ones. Show how to solve the problem and complete the chart. Now see how this chart has 4 squares? In each square, we're going to show how to show this as a different way. So the first way to show 32 pencils would be 3 boxes of 10s, and see, just like a 10s and 1s chart, there's a line down the middle, and the 10s are on the left, and the 1s are on the right. So we have 3 boxes of 10 for 32 that represent 30, 10, 20, 30, and 2 single pencils which represent 2. So we can just trace these 1, 2, 3. And so that's 3 tens or 3 boxes of 10, and then 2 singles, which would be 2 ones. And we know that 3 tens and 2 ones equals 32. Now in our next little drawing, we took away one of these tens and we broke it apart into 10 ones. So now we are down to 2 tens, and remember our pattern, it goes 3, 2, 1, 0 on the tens. But every time we take away a 10, we have to add the 10 to the ones. So now we have 12 ones. So as the number of tens decreases, which means goes down, the number of single pencils increases. So, and see how this is 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 ones. So go ahead and trace those. Now, if you can see the pattern, we know that in our next square, we're only going to have 1 10. So we draw 1 10. That means that we have taken we have taken a 10 from here and turned it into 10 ones. And so now, instead of 12 ones, we are going to have 22 ones. So that's a lot of ones that we're going to have to draw. But we'll try to draw 22 ones neatly right here. And we can draw 2 groups of 10 and then 2. So let's try that. So for this square, we just show 1 10 and we show 22 ones. There's 10. That's a nice neat 10. And this is really 10. That's another 10, so 20 and 2. So we have 1 10 and 22 ones. In the next one, we're taking away this 10 and turning that into into ones, excuse me. So now instead of 22 ones, how many will we have? We will have 32. The tens decrease by 1, and oh, that didn't turn out. And the ones increase by 10. Let's try to make that. We'll try one more time to make a good 2. There we go. Okay, and so now we've got to draw 32. That might take us a little while. So you may have to pause the video to draw those. Okay, when we finish drawing 32 ones, that's a lot of ones to draw. We have groups, we have 3 groups of 10. See, there's 10, there's 20, there's 30, and then our little ones, 31, 32. So that's 32 ones, and see, we have no 10s in the 4th one. And so that's how we can show 32 4 different ways. Okay, now we'll move on to the next page. Let's try another problem. On this page, Sarah has 36 crayons. She can pack them in boxes of 10 crayons or as single crayons. What are all the ways Sarah can pack the crayons? So up at the top, we have our little cloud that says, what do we need to find? What information do we need to use? So let's go ahead and underline what we need to find. We need to find all of the different ways that Sarah can pack the crayons. And what information do we have? Well, we have how she can pack the crayons, which is in boxes of 10 or as single crayons. So there are 2 different ways she can pack. And remember our pattern, we can do this as a pattern. Well, if she can do 3 for 36 crayons, she can do 3 boxes of 10s. Now notice here's the 10 and it's on the left. So this is almost like the 10s and here's the 1s. Another name for 1 all by itself is single. And so the 1s would be over on this side. Now, if we take one of the 10s away, what is 3 take away 1? How many 10s will we have left? We will have 2. 2 10s left. But we have to give that 10 over here to the 6 single crayons. And so if we increase 6 by 1 10, that means there's a 10 and there's a 1. So now we have 16 1s. So 2 10s and 16 1s is still the same as 36. So if we take another 10 away from 2 10s, 2 minus 1 is 1. But we have to add that 10 to the 16. So we go 6, 16, and what would be 10 more? 26. We're almost at 36. That's how many crayons Sarah has. So 3, 2, 1. Do you see a pattern? 3, 2, 1, 0. And if we add 10 to the 26, see there's a 1, there's a 2, and the 6 stays in the 1s. So we have a 3, 36. So she could pack 36 single crayons with no boxes of 10. And in our next problem, Mr. Winter is putting away 48 chairs. That's a lot of chairs. That's like 2 classes. He can put away the chairs in stacks of 10 or as single chairs. So what are all the ways that Mr. Winter can put away the chairs? Remember our little bubble up there. What do we need to find? Okay, let's see what we need to find. We need to find all the ways. What are the ways? The ways that Mr. Winter can put away the chairs. And what information do we have? Well, he can put the chairs in stacks of 10 or as single chairs. And if we look at our chart, it's just like this is the 10s, stacks of 10 chairs, and this is the 1s, single. So we start out with 48. So we can just trace over the 4 stacks of 10, and then 8 single chairs. So that makes 48. Can you imagine how that would look? Chairs, remember when we stack chairs in the classroom? I don't think we can stack 10 because that might fall over, but these are special chairs. So you can count by 10s if they're in stacks. Now remember, we're going to take a 10 away. So if we take a 10 away from 4, we have 3. And if we add that 10, we will have, we add the 10 to the singles. How many will that be? 18. Okay, then we're going, remember, we are taking 1 10 away every time, so it is decreasing. Decrease means get less. So Taking 1 away from the 3, that's 2. But we have to add that 10 over here. So if we add a 10 to 18, we have 8. Then we have 1 8 for 18. And then add 10, we have 28. That's 2 8. Then take away another 10. And we only have 1. Add that 10 to 28. And how many do we have? 38. See, do you guys see the pattern? Get that little 38 over here. There we go. Okay, 4, 3, 2, 1, 0. That's right. If we take another 10 away, we'll have 0. And when we add that 10 to 38, we have 8, 18, 28, 38. Counting by tens, 48. And that is how many chairs Mr. Winter is putting away. 48. So going down to our math talk, describe the pattern that helped you solve exercise 2. So let's look at this pattern and we'll talk about it as a class. And then we'll go to the next page. Okay, on this page, it's called Share and Show. Again, we are going to find a pattern to solve. Philip is putting 25 markers into a bag. He can put the markers in the bag as bundles of 10 or as single markers. What are all the ways Philip can put the markers in the bag? Okay, bundles of 10 markers, remember, that's like tens. And single markers are like ones, that's right. So we have tens and we have ones. So just try to imagine the bundles of 10 markers. So what do we need to find? We need to find all the ways that Philip can put markers in the bag. And what information do we have? He has 25 markers, and he can put them in bundles of 10 or as single. So those are our important pieces of information. So if we go to the bundles, if there's 25 markers, that means 2 tens and 5 ones. So that's like 2 bundles of 10 and 5 single markers. Now, if we break apart one of the tens, how many tens will we have? If we take one of the tens away from the 2, 2 minus 1 is 1. But then we give that 10 to the over here in the ones column. And instead of 5 singles, we're going to have 10 more, which would be 15. Then if we take another 10 away, 1 minus 1 is 0. And if we add that 10, it will be 25. Okay, and we'll move down to the next problem now. In this problem, stickers are sold in packs of 10 stickers or as single stickers. Miss Allen wants to buy 33 stickers. What are all the ways she can buy the stickers? So when we look at the 33, we want to think of that as 3 tens and 3 ones to start out with. So let's go ahead and underline the important information. First of all, what do we want to find? We want to find all of the ways There we go. All of the ways she can buy stickers. And now the information that we have to use is that she can buy 10 stickers, packs of 10 stickers, or single stickers. And of course, when we go here, she has 33 stickers. So let's see how we can show that. Okay, so the first one, remember, 10s and 1s. So a package of, if she is buying 33, that would be how many 10s? 3. So she can buy 3 packs of 10 stickers. So that's 10, 20, 30. And then 3 single stickers. And that makes 33. Now, if she trades one of those 10s and gets rid of one of the 10s and trades that for 10 1s, 3 minus 1 is 2. And then we have to add those 10. We just took a 10 away and we add that to the 3. And now there are 13. And remember our pattern, we take a 10 away. So if we take a 10 away from the 2, we have 1. And we add that 10 over to the singles column. So add a 10 to 13, we have 23. So 3, 13, 23, and we're getting up there. So in our last column, if we take that last 10 away, we'll have 0. And if we add a 10 to 23, we will have 33, exactly how many she needed to buy. Okay, and now we're going to go to Math on the Spot and find out how to solve this problem. Now, during Math on the Spot, we're going to follow along with our puppet Joey and Professor Rena, and we're going to solve this problem. So please keep your paper with you. Keep it handy during the video, and you can follow along and fill in the table with the information. So let's go straight to Math on the Spot.
Oh, that's so JoJo. No. That's so Cha-Cha. Oh, that's so Hao-Zoo.
Hi, Joey. What are you doing?
Oh, hey, Professor Rena. I'm just figured out that I'm missing something.
Oh, your socks?
Really? No,
What then?
a catchphrase. You know, every really cool person has a cool thing that they say all the time. Yeah, so my favorite so far is this. That's Attical, dude.
Attical.
You like, huh?
I do.
All right.
Well, I tell you what. How about we do our math problem, and when we're done, it might inspire you to think of others.
Oh, that'd be totally triangular, man.
Devin had 32 baseball cards. He gets 7 more cards. And he can pack them in boxes of 10 cards or as single cards. What are all the ways Devin can sort the cards? Now, what we're going to do to figure this out is we're going to find a pattern to solve.
Oh, like plaid, man.
Yes. Okay, so we're going to save the talk about what this table is for a moment, okay?
All right.
So let's start with the idea that Devin has 32 baseball cards. I'm going to write that down. 32 baseball cards. I'm going to move that up a little bit because I know I'm going to write a lot today. Okay. And he gets 7 more cards. So what does that mean? That means we're going to add 7 to his previous amount. 32 cards plus 7 cards. Okay, now how much is 32 plus 7? Let's figure this out. Using a quick picture, we can write 32 as how many tens?
That would be 3.
1, 2, 3, that's right. And how do we write 2?
You make the little circles.
Yep, 2 of them.
1 and 2.
You got it. Now, 7 is no tens and 7 ones. 1, 2, 3, 4, 5, 6, 7. Yes. Now, to find out what 32 plus 7 is to combine all of the ones together. So how many do we have? Let's see. First of all, we do have those 3 tens, 10,
Right.
20, 30. And then we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 ones. In fact, I have a fun little graphic I'm just going to pull on. It's 9 ones. You can see we can count it all over again, but
Yep.
that is 9.
All right.
Okay.
Yeah.
Now let's go to the table.
Okay.
There are many ways Devin can organize his cards. He could put some of them in boxes, put the rest of them in just a stack of singles, or he could put none of them in boxes and put all of them as singles. There are lots of different ways.
He's got a lot of decisions to make.
He does, right. So let's take a look at what we have right here. This is 3 tens and 9 ones.
Right.
Okay, well, when he puts the cards in boxes, he puts them in boxes of 10.
Okay.
So 10 cards go in one box.
All right.
So look, we have 3 tens. So that means how many boxes will he have?
Well, we'd have 3.
He'd have 3 boxes.
Tens would take 3 boxes.
That's exactly right.
Right.
And then there are 9 left over that he'll just leave in a stack somewhere.
9 in a stack.
That's right. All right, so we have 3 boxes of 10 cards and 9 singles for our 39 cards. I'm going to write that
Yeah.
39 right up here. Okay. Now, there are other ways to put the cards in boxes. Okay? So,
Okay.
for example, suppose he only chooses to have 2 boxes of 10 cards. So how many single cards would he have in one stack? Well, let's see. How about I just simply take, whoop. We don't want to do anything
Settle down
funny here.
there, sister.
I know what I have to do. I have to select it. Here we go.
yeah.
Okay, so what I'm going to do is I'm going to take this box of 10 and I'm going to replace it with 10 singles.
Okay.
Okay, so I'm going to take this off.
Bye-bye.
Bye-bye, and we're going to move this over, make room for 10 singles.
And there you go.
You see that? Okay.
Yeah.
So now we have 2 boxes of 10, and how many singles? Well, let's see. This was a stack of 10.
Right.
11, 12, 13, 14, 15, 16, 17, 18, 19. All right. So what we have is 19 single cards.
I get it. I get
Yes. Okay.
it. Yeah.
Well done. Now, there is another possibility for the number of boxes of 10 that he has. Can you think of what it would be?
Maybe just having 1 box?
That's right. 1 box. So if we just had 1 box of 10, that means we're going to take one of those boxes of 10 away and replace it with 10 singles.
Right.
Okay, so let's see how many singles. Well, we have 1 box of 10, right? And how many singles do we have? This is 10, 20,
and then you have the 9 ones.
Exactly. So all together, how many ones do you have? 29. 29
I
ones.
see.
Okay. Finally, well, what's the last possibility?
Well, he doesn't use any boxes?
That's right. And do you see a pattern here? 3, 2, 1,
Zero.
0. Good job. No boxes.
Hey,
Now,
hey, look at the other side.
yes, yeah. What?
Is there a pattern there?
Oh, yes. Take a look
It's
at the
not
pattern.
plaid.
Right. What's the pattern? Well, how do we get from 9 to 19? It turns out that's 10 more. 9 plus 10 is 19.
Right.
19 plus 10 is 29.
29
I don't know. Can you think? What's 29 plus
plus
10?
10? Well, that would be 39.
It would be 39. Oh, you're so good, Joey. And let's just confirm this with a picture. If I replace this one box with no boxes
Right.
and 10 singles instead, we'd now have 10, 20, 30, and this
the
9, which is 39. Very
Well,
good.
How about that? Devin's one cool cat.
Yes, he is. All right, let's take a look at the pattern one more time.
Okay.
Do you see that when he went from 3 boxes to 2 boxes, the number of single cards went from 9 to 19? That's 10 more than what he had before. So every time you have one fewer 10, you will have 10 more ones.
Whoa. So wait a second. So every time you take away one box of 10 cards, you get more single cards?
That's right.
And it's 10 more single cards?
That's exactly right.
Whoa.
Well done. You are so smart.
That's because you're such a good teacher.
Aw, thank you, Joey.
Yeah, but there's still that problem I have of finding my catchphrase.
Oh, okay. Well, let's do that.
What about count that?
Yeah, I like it.
Hey,
Or
yeah.
have fun with math.
Have fun with math?
Yeah.
That's a great catchphrase. Oh, can I use it too?
Sure.
So, hey, have fun with math. Have fun with math. Yo, have fun with math.
Have a great math day.
Oh, that's another great one. Have a great math day. Have a great math day.
Okay, that was a long one because sometimes math problems do take a long time. So let's make sure that we have this filled in properly. Okay, first of all, Devin had 32 baseball cards, but then he gets 7 more cards. So that's very important, and that's why we, in the video, we had to add 32 plus 7. And 32 plus 7 is 39. So as we were going through, we started out, 39 starts out with, could be 3 10s and 3 boxes of 10 and 9 singles. And then we take a 10 away and we're left with 2 10s and 19 singles. Then we take a 10 away and we're left with 1 10. But remember, we add those 10s over to the singles and we're at 21. And then our last possible combination, when we take the last 10 away, if you take the last 10 away, you're left with 0. And if you add that 10 to 29, you're at the next 10, which is 39. Okay, good job there, boys and girls. And going to our last page. Now this one says on your own, and of course that will be up to your teacher if you're going to do this one on your own. But it may be a little difficult. So if your teacher says go ahead and do it on your own, then you can do it on your own and then come back and pause the video and come back and check. But there's a lot of information, so we're probably going to have to do a little bit together. So solve. Write or draw to explain. Look for structure. And structure can be sort of like a pattern. Lee can pack her toy cars in boxes of 10 cars or as single cars. Which of these is a way that she can pack her 24 toy cars? And circle your answer. So she has 24 toy cars, and we want to find out which is a way, let me underline that one, which of these is a way that she can pack her 24 cars. So she can pack them as 10 or she can pack them as single. Okay, what if she had 4 boxes of 10 cars? Do you know, can you count by tens 4 times? Well, that would be 10, 20, 30, 40, and 2 singles. 40 plus 2 is 40 plus 2. Does that equal 24? No, that equals 42. So we're not going to circle this one. Nopa, nopa. Then how about 1 box of 10 cars? Okay, 1 box of 10 is just 10 and 24 single cars. Let's see, that would be 1 box of 10 would be 10. Oops, 10 plus 24. What do you think 10 plus 24 is? Well, that's 34. So that doesn't equal 24. How about 2 boxes of 10 cars and 4 single cars? Well, 2 boxes of 10, 10, 20. 20 plus 4 equals 24. So which one do you think shows 24? Well, if you pick this one, you are correct. 2 boxes of 10 cars plus 4, that equals our 24. And for our last problem, Mr. Link needs 30 cups. He can buy them in packs of 10 cups or as single cups. What are all the different ways he can buy the cups? Find the pattern to solve. Okay, so we want to know all the different ways that, we'll try to get that line here, all the different ways that he can buy the cups. And we know that he can buy them in packs of 10. You know, a lot of things come in packs of 10. And then sometimes you can just buy a single cup like this. And how many does he have to start with? He has 30 cups. So how can we start that in packs of 10? Well, we can look at 30 as 10s and 1s. So 30 has how many 10s? 30 has 3 10s and then 0 singles. So he could actually buy 3 packs of 10 and he'd have 30. But what if he took one of those 10s away and we find our little pattern and we take 1 10 away and we make 2. So now he has 2 packs of 10 and we have to add that 10 to the singles. So that's actually 10. And then if we take a 10 away from the 2, that would be just 1 package of 10. But then we have to add 10 to 10. What would 10 plus 10 be? That would be 20. And then if we took away another pack of 10, 3, 2, 1, 0. But we'd have to add that 10 to make, in order for these numbers to add up to 30, 0 plus 30 is 30. There we go. Choose 2 ways from the chart. Explain how these 2 ways show the same number of cups. Okay, so we can choose 2 different ways. How about we try we'll do 30 as 3 tens and 0 singles. So we can say 3 tens and 0 ones equals 30 plus 0. And then we can put another equals, oops, not plus, equals 30. And then let's do this. 110 and 21s equals 10 plus 20. And 10 plus 20 equals 30. So those are two ways that we can show that all of these actually equal 30. And this is why. Okay, I hope you had fun in math and even more fun with your homework. Good job, boys and girls.